right, so let's go over these different shapes and the angles that create them. So, taking a look at this first shape, you can see that it's a rectangle. It has four sides. Opposite sides are parallel. And when I look at all the angles, they all seem to make this square corner. So, you should have placed an R for right angle inside that shape. Coming down here, I see one, two, three, four, five, a five-sided figure. You might already know the name of that kind of polygon, but if not, a five-sided polygon is called a pentagon. Now, when you look at these corners, these angles here, it's a little hard to tell, but this looks a little bit larger than a perfect L. And all of these angles are actually the same. If you had a piece of paper, we often would tell you to turn your paper so you can take a look and see what those angles look like. But you should have put an O for obtuse because all of these angles are obtuse. So now let's take a look here at this triangle. All right, so you can see that we definitely have one square corner or one right angle. And then I notice that these other two angles are smaller than a right angle. So I'm going to drag the acute in here. So far, I hope that you've been doing okay with these first three examples. If not, that's all right. Just go back and take a look at where your mistakes could have been and go ahead and make those adjustments on yours as well. All right. So up here, we have another four-sided figure. And we said a five-sided figure is called a pentagon, a four-sided figure. And I saw some of you even said that you did this over spring break. You rode a four-wheeler. So if you think about what else you call your four-wheeler, we call that a quad. So that means four, and a four-sided figure is called a quadrilateral. So both of these are quadrilaterals. This is a special quadrilateral called a rectangle. And this one here is a special quadrilateral, and we call it a trapezoid. So when you take a look at this trapezoid, I see that these bottom two angles are congruent or the same, and they both look to be smaller than the letter L. So I'm going to drag the acute circle in. Then when I look at these top two angles here, those also look congruent with each other. Congruent is a term in math that means the same. So when I look at this and this, I can see that they are opened up larger than a square corner. So those are obtuse. Speaking of quadrilaterals, I see one more on this page, and we're going to do that shape next. So go ahead and see, can you figure out which other shape is a quadrilateral that we haven't done yet? If you were thinking this one, good job. Now, this is also a special quadrilateral because the opposite sides will never touch. So that is called a parallelogram. We are going to be studying more about quadrilaterals later on in our geometry unit, but it's good to get used to these terms now so that way they are familiar to you when we get going. So taking a look, I see some congruent or similar angles in this quadrilateral too. I notice that this angle right here is opened up larger than a square corner, as well as the one on the opposite side diagonally is also larger than that right angle that we use as our benchmark. So we're going to drag the obtuse circle in here. Now, these two angles are definitely different than the first ones we looked at in this shape. And you can see that these are smaller. If I wanted to try and draw a square in there, I couldn't do it. So that means that they are acute. All right, coming over here, we have a special kind of triangle. All the sides are equal on this triangle, so it's called an equilateral triangle. And we will be talking about triangles today and a little bit tomorrow as well. Or excuse me, not tomorrow, on Thursday. So when you look at this one, I can see that all of these angles look very similar. And if you remember what that term is for angles or lines that are exactly the same, we call that congruent. And I can see that they all definitely look smaller than our benchmark right angle. So all of these angles, you should have put an A in there for all acute. Coming down here, I can see with this one, these two, if I look at the top of this shape, I definitely see that it kind of looks like a square without, if we weren't looking at this bottom part, or maybe this rectangle, very similar. So I see those right angles at the top here and here. And believe it or not, this one is actually a right angle too. Again, it's kind of hard when you don't have that flat line as your base, but if you turn your head or your computer, you might be able to see that. But then I also have these two other angles right here and here. And those two angles are obtuse because they are larger. So again, let's see, we have 1, 2, 3, 4, 5 angles. If you didn't know this, the number of angles is always equal to the number of sides. So if I have 5 angles in this shape, I also have 5 sides. Do you remember what I called a 5-sided figure earlier in this video? If you look back at this shape, this is the other one that has 5 sides and angles, and we call these two shapes pentagons. On our last one here, it looks very much like a stop sign. And you can see that all of these angles are congruent and they are all opened up larger than our benchmark right angle. So we are going to put the O in there for all obtuse angles. Now, if you go ahead and count the number of sides or the number of angles, we just talked about how they should be exactly the same, you'll see that this is an 8-sided figure. And you might know this term already, but if you think about an animal that has 8 arms, what that is called, you might have a clue to where we're going with this. So that 8-armed animal I was talking about was an octopus. So this is actually called an octagon. All right, so good job reviewing our angles. If you need more help with that, always go back to that chart where it talks about what makes each angle acute, right, or obtuse, and that could be a big help as we move forward with our lessons. All right. So taking a look at our next slide here, we are going to start to classify triangles by their angles. And I know that I've introduced you to a lot of vocabulary terms already today, but we're going to take a look at these two that are very important. This word attribute is going to come up a lot in this unit. Any characteristic of an object or shape, such as a number of sides or angles, or the length of the sides, or the measure or type of angle, we can call an attribute. And then down here, you can see that we're classifying. And classifying is when you group things into categories. So we're going to group or collect objects together based on similar attributes, meaning these qualities that they have in common. So if you think back to that other slide, we talked about how we could group different shapes as quadrilaterals because they all had 4 different sides. We could also group them by the types of angles they have. So this is what we're going to be doing today. We're going to be looking at attributes of triangles, and we're going to group them into categories based on their angles. So there are 3 types of triangles when looking at their angles. We can either call them acute triangles, right triangles, or obtuse triangles. And again, you hear those angle vocabulary terms coming back into this. So taking a look at this first triangle right here, you'll notice that every single one of these angles looks smaller than our benchmark. Now remember that if a triangle is a 3-sided shape, that means it also has 3 angles. So we're going to call this an acute triangle. Why? Because all 3 angles are acute. So again, if you're looking at a triangle and every single angle is acute, it's called an acute triangle. Coming down to this one here in the middle, you can see that, well, these 3 angles don't all look like they're the same. 2 of them are acute, but this one here makes that square corner, that benchmark angle called a right angle. And that special angle will be what we use to classify this triangle. So we're going to call this one a right triangle. Why? Because there's one right angle. The other two will always be an acute. If you think about it, it's impossible to actually draw a triangle with two right angles. If you don't believe me, go ahead, get a piece of paper and try it. But again, we're always going to look at that one special angle that's not acute to label this as a right triangle. And then the last one we have, if you look here, you can notice that again, we have two acute angles, and then that last one is larger than our benchmark, and it makes an obtuse angle. So we're going to call this an obtuse triangle. And again, why? Because there is one obtuse angle. So now let's take a look and practice some more. So you can see here, I have 6 different triangles, and I want you to take a look at the angles because, again, that's what we're doing. We're going to identify them based on their angles. That's our attribute we're using to categorize them as either an acute triangle, obtuse triangle, or right triangle. So when I look at this first one, I can see, all of these angles look smaller than our benchmark angle. So I'm going to call this an acute triangle. I would like for you at this time to pause the video. Go ahead and look at these examples. Go ahead and also decide what type of triangle this is. When you're done, come back and push play on the video and we'll see how you did. All right, welcome back. So let's take a look. Number 2 here. I see that these two are small, but this last one over here is an obtuse angle, and that one being different is what we're going to use to call this an obtuse triangle. Taking a look at number 3, you can see that, there's one right angle here and the other two are acute. So we're going to use this special angle right here. And this is a right triangle. Hopefully you're doing pretty good on those first 2 examples. All right, number 4. Again, I see a special benchmark angle in this triangle right here. So we're going to call this one a right triangle. Then I have this one right here, and you can see, all of these look like they're smaller than the letter L, meaning that opening right here, smaller than a square corner or a letter L, which is that benchmark angle that we're using. So this will be an acute triangle. And the last one here, number 6, you can see is an obtuse triangle. Sorry about that. I just moved the screen. But you can see it's called that because this one angle right here is larger than the rest. So at this time, I'm asking you to go to the next slide. You are going to go ahead and complete the Google form. Don't forget that I included a game on there called Banana Hunt. I really enjoy playing it, as well as don't forget to submit your presentation when you're done. If you have any questions, please reach out through email. And you guys did a great job yesterday with angles, so I think you're going to do a really good job applying those angles to triangles today. All right, good luck. Do a good job.